Howdy. I've been in the shop and noticed some empty shells. It seems to start also to be seen here supply chains disruptions and stuff like this. So we might have to talk a bit about weather because it is very important. It's very important for our food, for humanity, or living beings in overall. Yeah, also for the living beings, because if the living beings don't get sunlight and water and stuff they need, they don't grow, you cannot eat them. I've been watching a bit YouTube. Yeah, and it's about water. And I wanted to show you a little part of this documentary. I will put a link below down that you can watch the whole documentary for yourself, but let's have just a listen to this.
But what role did climate change play in the Our Valley disaster? Was that the ultimate cause?
I would argue that the scale of the flood is not necessarily climate change related, but in terms of the frequency, in other words, how often such events occur, you could argue that changing weather conditions mean that floods are now occurring more frequently, and that's a consequence of climate change.
Climate change increases the likelihood of such events occurring more frequently, as demonstrated by a recent study conducted with the participation of the German Meteorological Service. Yet the question remains, why is weather becoming more extreme? We meet Sven Plöger at the Weather Center of Germany's main public broadcaster. Some 35 forecasts are produced for weather bulletins here every day. Plöger's job includes analyzing maps and figures. The TV weatherman has observed that a number of weather phenomena have become increasingly common.
This here is a 50-knot wind.
Plöger tells us about the standing waves phenomenon, high pressure and low pressure fronts that don't actually move. It explains the devastating storms in the Ahr Valley, the Sohnwald, and Braunsbach. It's highly uncommon for high and low pressure fronts to be stationary, but it's become a feature of current weather patterns.
Storms that move distribute rain across a wider area. If they don't move, the impact is concentrated in one place, so there's extremely heavy rainfall. If the high pressure front doesn't move, then we have the high temperatures and drought we saw in 2003 or 2018. At the moment, we're seeing more frequent standing waves and also more frequent stationary highs and lows. So that's a hypothesis that's being investigated right now. In scientific terms, it's not straightforward. The natural world is always complex.
So, I wish I would have this kind of computers they just use there in this weather office, but I don't. I have this old crappy cheap laptop on which I try to get my mountain water paper written. But it's so slow, it's unbelievable the amount of frustration every now and then. You cannot watch Windy on it, you cannot do anything, hardly watch like YouTube videos, but that's it. You cannot do anything with it. So it's not. I try to watch Google Earth, but doesn't work because it's just like crap. So I have a phone. All my videos are done with a phone. I tried to make once a video with a computer, but it doesn't work. So he was talking about the standing waves, about those high and low pressure systems, which all of a sudden don't really move anymore, like they have done in the past. And as he states, nature is very complex and they are investigating the thing. Let me share with you some thoughts about it, what I have like I came to the conclusion it has to be so because there's such a big amount of evidence. Some of the stuff I found by myself by watching the weather. I have been watching the weather all my life, long before anyone invented some modern day cell phones with windy application and stuff like that. So, I have been watching Windy, and about 2 years ago or something, maybe more, I don't remember exactly. I recognized some repetitive pattern above Europe, Scandinavia, and stuff. So I made some investigations. I tried to educate myself and also started to think by myself, gathering information about all kinds of things, learning. And it doesn't stop. It will never stop. There's too many things I have no idea about. But let's talk about weather. Some of you may remember this map. Some maybe haven't seen this ever. Anyway, that's the surface conductivity anomaly in Scandinavia. Here is Finland. Somewhere is the border to our neighbors. It goes up here and stuff. Here we have Sweden, Norway, Denmark, the Baltic states. Here is Germany, Poland, and St. Petersburg, where we have SO2 emissions almost constantaneously, which is also another very interesting thing, but we won't dive into this now. Here in the south, we have the Kursk magnetic anomaly. Kursk. And I won't dive into this either now. But anyway, I have been playing around with this map, and somehow this is the one I like the most. I don't know whom to ask about this. I tried to ask many people, Finnish Meteorological Institute and stuff like that. No answer. They have no idea. One professor just told me, yeah, he doesn't know anything about that, and recommended me to ask another one, which seems to be higher in this whatever university educational hierarchy system. I asked him, didn't get any answer, so I asked again, and I still didn't get any. I don't have any answer. You would know that. I would have shared it. But anyway, this other man before in this documentary was talking about those high and low pressure systems, which don't really move anymore as they did in the past. That's why we got those extreme droughts, because the high pressure system is just stuck in place. Heavy downpours because the low pressure system is just stuck in place. And scientists don't know really what's going on, because you cannot blame this thing on CO2. Just doesn't work. There has been those floods in the Rhine area. Was it 2 years ago? Somewhere here? No, it's not. It was here. In the G point. Where we have also the Lachersee, and the place which got flooded was Koblenz. You can read it up if you are interested. So, if you take a look at this signature, yeah, that's a very it's made with a phone, this picture. There's no overlaying possible. So I just try to fit the screenshot as good as possible onto Google Earth. simple. If you look at this, I interpret this as following. That's plus or north. The blue ones are negative or south, however you want to put it. And it has this distinct, let's say, shape. And we have to remember. And anyway, no, I won't take now too far. But just look at the shape of these things, of this surface conductivity anomaly. The plasma rocks, where you find a playlist, is here. You can check them out. I recommend you to take a look at the plasma rocks. There are many videos which don't have any words or whatsoever because it's about the rocks. Just look at them. But anyway, if we take a step back, like a really big one, and look at the bigger picture, that's Earth. You are here. I am here. Everyone is here. Everyone we know. So, up here are the polar cusps, and here is written the incoming solar particles. They will come in at the poles, and others will come in at the equator. These are the places where we have Aurora Borealis or Aurora Australis, hence polar lights, because the energy is coming in. And this stream, sorry for saying and all the time, that's a Birkeland current. Birkeland current. So, taking a closer look on the polar cusp, this region here, we will notice something interesting. This seems to look like this, the cusp reconnection. That's the part up there. And it has somewhat striking similarities with the surface conductivity anomaly in Scandinavia, which basically means we are watching at electromagnetism. The surface conductivity anomaly in Scandinavia is petrified electromagnetism. At the plasma rock site is, besides many other very interesting things, there is molten metal on top of a rock, created by a lightning strike. You can check it out in the Thunderbolts video, The Shocking Truth. There are a few pictures of the plasma rocks too. After I learned certain things and went to the plasma rock site, as I call it, as I started to call it afterwards, after learning a few things, I seen this little spot with the molten metal. Maybe I should search it. Yeah, I found it. That's metal on top of a rock. Now everybody knows that lightning strikes, they can be lethal and they can put stuff on fire and all kinds of things. So it's very common knowledge for everybody that the heavens can make the connection to the ground. Rain, snow, hail are all discharge events. not only a lightning strike. And furthermore, we also know that lightning strikes, or lightning, can be positive, which means it goes upwards first, and then it makes a connection. And yeah, if you watch the video, I think I put a link below. It's not about making what commercial or something out of me. It is more trying to prove that I, in a way, probably have understood few things at least. There are many other things I have no idea, like I said before. Most of the things I have no idea. I guess there are so many things. What's your shoe size? I have no idea. So there are so many things I don't know. But in a few things I think I got it. So that's just in order somehow to put some kind of evidence or proof behind of the things I try to explain. Like this. Wikipedia. Telluric currents, or earth current, is an electric current which moves underground or through the sea. Telluric currents result from both natural causes and human activity. And the discrete currents interact in a complex pattern. The currents are extremely low frequency and travel over large areas at or near the surface of the Earth. Telluric currents are a phenomenon observed in the Earth's crust and mantle in September 1862. Funny. If I would be good in math, I could count 22. No. Yeah, that's some time ago. An experiment to specifically address Earth's currents was carried out in the Munich Alps, including minor processes that are at least 32 different mechanisms which cause telluric currents. The strongest are primarily geomagnetically induced currents, which are induced by changes in the outer part of the Earth's magnetic field, which are usually caused by interactions between the solar and the magnetosphere or solar radiation effects on the ionosphere. Telluric currents flow in the surface layers of the Earth. The electric potential on the Earth's surface can be measured at different points, enabling the calculation of the magnitudes and direction of the telluric currents and hence the Earth's conductance. These currents are known to have diurnal characteristics wherein the general direction of flow is towards the sun. So we have to remember that energy flows always both ways. Telluric currents continuously move between the sunlit and shadowed sides of the Earth towards the equator on the side of the Earth facing the sun. That is during the day, and toward the poles in the night side of the planet. So now, let's go back to the video. Let me draw first a very sketchy picture. That's Earth, with all its geological features. Some are plus, some are rather minus, hence mountains and their valleys. Minus, plus. And charge tends to accumulate on peaks. We have our Earth's magnetic sphere is weakening, the poles are probably shifting or at least experience an excursion. We are about to experience the 12,000 years cycle of the sun, which is a rather rude one. if you take the half of it, 6,000 years, it wasn't very pleasurable to be there either, because many tales have been told since then. Tales like Noah's Ark, the deluge, many dragons emerged from these times. Dragons are basically weather phenomena, roaring winds, supersonic, lightning strike, lightning strikes no one ever could imagine. Ground to cloud to ground discharge, arc discharge from continents to continents, or from suitable places to other suitable places. Massive earthquakes crumble the mountains and heavy winds carry them away. Water will be everywhere, it will rise from the ground, it will come down from the heavens, it will make one connection. There's just one water after all. Or for a while, because the heaven came down to earth. You are in a cloud, you are in water. Which is never clean, there's all kinds of stuff in that. Rocks, poison, viruses, everything. So our magnetosphere is weakening. We are into the 12,000 year cycle. All other planets have experienced changes recently. They are proven, except Mercury. But it maybe in some little time it will be also confirmed that also Mercury has changed very recently. Neptune's changing storm and all these kind of things. So it's proven. Is it the galactic current sheet which is hitting our solar system? A dust cloud? And you know, if there is a place where they make a flour for baking, if there is a flame, it will explode, like, you know. So there's a dust cloud coming into our solar system, which has a glowing heart, our sun. So imagine if there's dust coming, what will happen with the dust? It will light up in one time, or it will at least disturb the sun's activity, and it's ramping up. Solar cycle 25 is very active. There's another big sunspot coming in. Is it 3088? I don't know. Maybe. The one which blasted the biggest ever recorded eruption just a week ago or something. Seems to be Earth facing in 5 days, maybe. If it's the same, I don't know. So, with all that said, weakening magnetosphere, we are down compared to about 100 years ago to 20 to 25 or even more percent. So whatever stuff is coming from the sun, it will have a bigger effect on Earth than it had 100 years ago, or 200 years ago, or 700 years ago, or 1, 2, whatever, you know, for a very long time. Now it's weakening, maybe shifting, or yeah. There is at least, for sure, more energy coming in. So whatever stuff is in the ground which can make a connection to the heavens, which is charged in a way, if you have an iron mountain, for example, like the coarse magnetic anomaly is, if there is a big amount of material which reacts with electromagneticity, like iron, for example, or whatever stuff, they will make a connection to the heavens. That's the reason why those weather systems don't really move, because it's just a stable connection from the ground to the heaven. If it's charged positively, you will experience high pressure system. If it's charged negatively, you will experience low pressure systems, because these are ancient imprints in Earth's crust, which more and more will interact with our atmosphere through their polarity, conductivity, and all these kind of things. So now let's just have a listen again to this guy, and now we leave it there then.
This here is a 50-knot wind.
Krüger tells us about the standing waves phenomenon, high pressure and low pressure fronts that don't actually move. It explains the devastating storms in the Ahr Valley, the Sohnwald, and Braunsbach.
Does it really explain? No. It doesn't explain. They just notice they don't move. That's no explanation. Still one thing. Let's go back to this just for a quick moment. I've been trying to draw some directions here. That's a high pressure system, it will spin in this direction. And the low pressure system will spin on the other side. So there will be this kind of channel here in the middle. So, these are ionic winds created by these electromagnetic connections. So every wind, all the winds you experience are ionic winds created by these currents between magnets, which carry energy. And the whole thing is created with a huge amount of electricity, like a lightning bolt, between planets or the clouds. That's why these weather phenomena are increasing in extremity. Higher winds and all these kind of things, because these imprints in Earth's crust will gain more and more in importance in order to understand extreme weather. Because Earth's magnetic field is weakening, so they are, in a way, getting stronger. Those imprints in Earth's crust. But we also have to take into account that Earth's crust might be shifting. Did it shift? How much did it shift? How accurate is, for example, this map? I don't know. But I leave it here. Thanks.